Hi, today we're going to look at Unit 1A, Day 7. We're going to review the last 6 days. So number 1, identify each geometric figure, then give all possible names for the figure. So A, I see a dot and a T, so I know that this figure is a point. And the only thing I can do to name a point is I can say it is point, and then it's capital letter that's attached to it, which is T. Make sure it's a nice capital T. The next one, figure B, is a or an. Well, this goes forever in both directions, so it is a line. And possible names, well, I see the lowercase cursive L on the end, so I know this is line L. But remember, you can also pick any 2 points in the line. There only happen to be 2 labeled, but remember, there's an infinite number of points. You can pick any 2 you want, and I can say this is line MN. Capital M, capital N with an arrow on both ends of our line bar. Or we could switch it around and say this is line N, M with the line. Both of those are correct. If there was a third letter on here, I could also choose that one as part of the 2 that I choose. Okay, number 2. Use the figure to answer the questions. All right, so on this one, name the intersection of line L and line M. So I see line L is this line here. Let's see if I can highlight it in the orange. And then I can see line M is this line here that I'm going to highlight in this green. And I can see that those 2 points, they intersect right here at point J. Capital J, and we said it's a point. What are 2 other names for line L? So again, I'm going to go back to line L, and I'm going to see here, it's already been used, line L, so I want 2 other names. So I'm going to look for points. I need any 2 points. Well, I only happen to have 2 points. I have an H and I have a J, so I have to use the H and the J on that line with my line symbol, or I can flip the order around and call this JH with my line symbol. Okay, so there's number 2. Let's look at number 3. Are the following points collinear with L? So are they going to be in line with this point right here, L? Okay, so that's what I'm looking to see. All right, so when I start with the first one, and I start with point J, is J, now it's only 1 point, right? So 1 point is going to be in line with L. That's going to be a yes. Okay, then when I look at point N, again, that's 1 point, which means I already know my line is, or my answer is yes, because I can connect L and N with a line. So that's yes. Okay, then the next one, point K, again, it's 1 letter, and so I know it's this line, which also happens to be the one that goes through J, so J and K are also collinear with L, both of those. So that's a yes. Now we have to really stop. We wouldn't have even had to look at those last sets, because if you have 2 points, so J and L, N and L, K and L, you're always going to say yes, because 2 points are always collinear on the same line. Okay, so again here, K and N, are they collinear with L? So if I look at K and N, and can I draw a straight line that connects K and L? No, I cannot. Okay, so we can see that that did not make a line, right? It had to curve to get around to L. There's no way I could connect those 3, so that one is going to be a no. Okay, let's look at L. Oh, well, look, this isn't even a point. So that's definitely going to be a no. Okay, that is not going to be, that's not H. While it kind of looks like it's naming the same line that L is on, H isn't a point, so you can't be collinear with the name of the line. Hopefully that makes sense. Okay, all right, the next one, M, K, N. Do those go with L? So let's see. N K, and M are all of these. So are they going to be collinear with L? L's not going to be on that same line. So that's going to be another no. Okay, and then points J and K. When I look at J and K, yep, sure enough, they're going to go also through the same line that L does. So that one is a yes. All right, let's continue on. All right, the next thing we're looking at is find the measurement of the missing segment. Assume the figure is not drawn to scale. Okay, so I want to find how far is it from G to H. So from G to H, this piece right here, I can see that G is on the segment. It's dividing the segment into two parts. So remember, our segment addition postulate says if you have a point on a segment, then you can look at the left side, FG, and then the right side, GH, and together, that's going to equal, if I add those two together, the left plus the green, that's going to equal the whole thing, F all the way to H. So then we're just going to substitute in, if I was doing a proof, I would substitute in all my givens. And I would say, oops, I didn't mean to put the FH there because I'm going to substitute in. And then I'm going to substitute in F all the way over to G is 9.7 millimeters. So F to G is 9.7. And then G to H, we don't know what that is, right? So I'm going to just leave that. You can change that into an X, what you're trying to find, or you can just even leave it GH. And then F to H, F all the way to H is 15. Okay, so then this is ready to be solved. Okay, to solve this, if I'm doing algebra 1, right, I'm just going to subtract 9.7 on both sides. On this side, that turns into a 0. And if I was doing this as a proof, I wouldn't do this math so like right in your face on there, because then it makes the rest of the proof difficult to read. Okay, so then G all the way to H is going to be 15 minus, I didn't put my minus symbol there, 15 minus, oops, I wrote 16, 9.7, which is 5.3. Okay, write your answers as a complete sentence using correct notation. So we can say, if we're trying to find the missing measurement, we can say GH, let's make it a complete sentence. Actually, you know what? We'll do the distance from, that probably didn't need to be capitalized, point G to point H, capital G, is 5.3, and my units are all millimeters. Okay. Number 5, write an equation to find the value of x if y is between x and z, and x, then find x and each missing segment. Okay, so the first thing I want to do anytime they give me something like this is I want to draw a picture. So y is between x and z. The first thing I'm going to do is find an x, find a z. Y is somewhere in between, and I don't like to make it look like it's right in the middle so I don't get confused. Once I do that, then I'm set up for my segment addition postulate. So I'm going to write that equation because sometimes it is really helpful. Other ways we get stuck. So x, y, the left side, plus y, z, the right side, equals the whole thing, right? Left plus the right gets me from x all the way to z. Okay? All right, so now what I'm going to do is I'm going to look at, if I was doing a proof, I'd call them my givens. X, y is 5x. Y, z is just x. So I can already tell if this is 5 times x and that's just x, then probably I didn't draw my picture to scale because this side should be much bigger than this side. It should be 5 times bigger than this side, but that's okay that my picture is not to scale. Okay? And then, last but not least, x all the way to the end at z is 25. So x all the way to z is 25. So now I'm going to bring down my math. I'm adding the blue and the orange together, and that's going to equal the whole green. Okay? All right, so look, there's my equation. I'm going to have 5x plus x equals 25. That's my equation. If you simplify it, if you say, oh, well, I know 5x plus x is 6x equals 25. If this was a free response on a homework or a quiz or a test, I would take either the 6x equals 25 or the 5x plus x equals 25 because those are equations. Okay? They're both equations. All right, so then all I have left to do is divide, and I think we've seen this one. Divide both sides by 6, and you can leave it as x equals 25/6. If you want to make it into a decimal, we are going to always round to 3 places. So I'm going to do 25 divided by 6, and I'm going to round to 3 places, which is going to be 4.167. So you can either leave it as 25/6, or we can say it is 4.167. Okay, so then for my xy, the xy is just 5 times x for xy. So I'm going to do 5 times our x, 5 times that 25/6, which is going to be 125/6. Right? Because think of it multiplying over 1. 5 times 25, 1 times 6. So 125/6, which as a decimal, rounded to 3 decimal places, would be 20.833. Both of these answers are correct. You only have to give me one. All right, and then the last one, yz, that they're asking me for, because they didn't have to ask me for xz because that's already, we know how that's 25, okay? So, well, that's just x. I know what x is. X is 25/6, or 4.167. Okay, so there is the answer to x, xy, and xz. All right, here's another one. Weird, my minus symbol got real low there. 2x minus 1, 6x, and xz. Let's see if I can make myself some room here. Kind of barricade these off. Tell the difference between these two problems. All right, again, I'm going to do the same thing I did last time. I'm going to draw myself a picture of what it looks like. Again, it's still this up here, right? Because A and B fall under this number 5. So we're going to have an x, we're going to have a z, and we're going to have a y somewhere. I don't know where. Okay? All right, and so I know I'm going to be doing xy plus yz equals xz. And then as I go through, I can see that xy is 2x minus 1. Let me make sure that's what I have, that it didn't do something weird when it converted in the PF. Okay. All right, 2x minus 1 for the left side. So I know xy here is going to be 2x minus 1. And then yz is 6x. So I may have made it more to scale this time. And I know that's going to equal the whole thing, 81. xz is 81. So my whole thing here is 81. Okay, so then the blue side plus the orange side, the blue plus the orange equals the whole thing that's green. Okay, so that's my equation over here, 2x minus 1 plus 6x equals 81. If you want to combine your like terms and simplify it to 8x minus 1 equals 81 and put that for your equation, that is absolutely okay. All right, so then we're going to add 1 to both sides. And if I was doing a proof, I would leave it just like this. I wouldn't do all of that because that gets really ugly and difficult to read this line of the proof. So then 8x plus 0 equals 82. Divide both sides by 8. I'm giving you all these problems that don't reduce. So, or don't come to a nice simple number. All right, so let's see. If I were to leave this as a fraction, it would be 41 over 4, or 82 divided by 8 is 10.25 as a decimal. So both of these are correct for x. So 41 over 4 or 10.25. Oh, I don't know why I'm putting it way up high like it's a fraction. 10.25. Now in this one, I don't mind using the 10.25 when I plug back in because 10.25 is what we call a terminating decimal. There were no numbers after that 5 going on in the calculator. Whereas up here, right after this 833, it just kept going 33333, and then here it kept going 7 or 666666666. So notice when I plugged it in, I used the fraction version, so I wasn't going to be taking this rounding error and multiplying the rounding error 5 times because that's 5 times the rounding error. Okay, so if you have a nice terminating decimal, there's nothing that keeps going and going, then go ahead and use that when you plug it in if you'd like, as opposed to the fraction. But if you don't have it, it's good to use the fraction just to eliminate some of that rounding error. Okay, all right, so then the next we're going to look at finding xy, which is 2x minus 1. And now we know x is 10.25. So that's going to be 20.5, right? When I do 2 times 10.25 is going to be 20.5. And when I subtract 1 from that, it's going to be 19.5. Okay, and then y all the way to z, so this right-hand side is 6x. So 6 times 10.25. 6 times 10.25 is 61.5. Okay, so then if I check, I didn't check up here. If I check 19.5 plus 61.5 should give you 81, and it does. Okay, it should give you that total distance. So my 19.5, 61.5 together makes that whole 81. Okay. All right, whew, that's a mess. All right, let's look at number 6. Number 6, we like number 6 because on number 6, it is going to be just counting, right? So that's always nice. So if I want to find the measure of LN, so I'm starting at L and I'm going to N, what's the distance between those two? So I have 2 ways to do it. If I want to do it using the number line, it's really simple because I can just count, right? I can just go from L to N. 1, 2, 3, 4, 5, 6. So I know it's 6 units. Be careful. Sometimes when we count, we accidentally count before we start moving. And we say, well, right when we get to L, we already start with 1, 2, 3, 4, 5, 6, 7. And then I've gone too far, right? So you don't actually count till you take a step, right? If you want to know how many steps it is across the room, you wouldn't start counting until you took that actual first step. You placed that first foot out. Okay. Algebraically, if you wanted to show your work algebraically, we would see that L is at 3 and N is at 9. So if we do 9 minus 3, we see we get our 6 units. Okay. All right, same thing. Let's do L to J this time. So for L to J, I'm going from L to J. Okay, and when we do that, if I start here at L and I count, it's 1, 2, 3, 4, 5, 6, 7, 8 units. Okay, and remember, we always do our distances positive. You can't have a negative distance. So I'm still going to start with this 3, the bigger number, and I'm going to take away the negative 5, the smaller number. So when I go 3 minus a negative 5, well, 3 minus the negative 5 turns into really just 3 plus 5, and that's how I get my 8. Or you can think of it as absolute value away from the end you started at. So if I do 5 and then I were to, or negative 5, you would actually be adding the 3 to get to that 8. So hopefully that makes a little sense. Or if you start here and you do negative 5 and then minus a 3, you'd have your negative 8, but it's the absolute value distance. So it's a positive 8. I hope I didn't just mess everybody up. Okay? All right. Okay, number 7, I'm just realizing it says write the equation to find the distance between the pair of points, then find the distance. But I didn't give you a pair of points to do. So let me see if I can find us a pair of points that I'd like us to look at. Let's do 2 points. Let me switch colors. My first point being, I'm going to say point C, and that's going to be negative 3, negative 1. And let's do the second point. I'm going to go with Q and negative 2, 3. Okay, the first thing, if you recall from my video that we did, is I fill in my formula without the x's and the y's, because then I can label my points and just plug them in. So I'm going to have my first point x1, y1, and then so my x1 I can now see as a negative 3. And if I hadn't have already written the formula, I might miss that, oh look, that's going to turn into a positive. And then my y1 is a negative 1. So y1 is a negative 1. And again, that's going to turn into a positive. All right, then this is going to be my x2, y2. So x2 is negative 2, and y2 is 3. So it's real tempting. You look at that to go, oh, that's going to be 0 because 3 minus 3. But remember, that's not really 3 minus 3. That is really 3 plus 3. And this is really negative 2 plus 3. Oh, wait, is that a 3? That's my y. That's a 1. Good thing I caught that now. Always check back in your work because sometimes we accidentally misread. Okay, so now my next step is I'm still going to write the D. I'm still going to write the equals. I'm still going to write the big old square root symbol because I don't want to forget it at the end. All right, so now I'm going to have negative 2 plus 3, that's 1 squared, plus negative 3 plus 1, that is 4 squared. Okay, so then D equals the square root of 1 times 1 is 1. 4 times 4 is 16. So D equals the square root of 17. It does say to round to 3 places. So I am going to do the square root of 17. And when I do that, I'm going to put it over here where I have a little bit more room to write. In the calculator, I get 4.1231056 It keeps going on and on and on. Okay, but if I want to round to 3 decimal places, 1, 2, 3 places after the decimal, I look at the 4th one to see if I have to round up, and I do not have to. So my answer is 4.123 units. Okay, so there is our quick review over days 1 through 6. If you have any questions, make sure you see me for tutoring. If my tutoring schedule doesn't work, we can look at the other geometry teachers on campus at their tutoring schedules, and perhaps we can find a time to get you in with a different teacher, okay, if mine doesn't work for you. All right, thank you so much for watching, and I will see you in class for the next lesson.